Alright, hi, this one, we're doing some.
Okay lah, start up lah, you know. Hi guys, welcome to our first podcast show, what we call Sembang Biotech. Today I have as a host, Jiva Kupusami from GT Aqua. I'm the founder and CEO. In the show today we have Dr. Gan, my longtime friend and also colleague as a partner and also an entrepreneur, and how we have gone through our journey in the industry of biotech and how we trying to democratize biotech. So just to give you a little bit of background about myself, my background is in degree, I'm trained by biotechnology. That's 2008, I graduated and I joined University of Malaya. Then I did my master's in aquaculture biotechnology. And soon after that, I went through about 15 years of learning curve in the industry, both in the farming, in academia, in industry. And 2017, I co-founded GK. And 2021, with this young gentleman here, we co-founded Patriot Biotech. There's another startup trying to aspire youngsters like us to come out on our own from comfort zone and try to do something to make the industry to thrive using our knowledge and experience to elevate income security, elevate poverty, so that we can thrive in terms of food security in the country. Over to my friend here, Gan. Why not introduce yourself a bit?
Can. Alright, hi everybody. So my name is Gan. For me, I did my undergrad. I was lucky enough, one of the few individual lucky enough back then to get a JPA scholarship to go to the United States to study biotech as well. I didn't spend long time there unlike most of my friends. I somehow, for some odd reason, I want to graduate as soon as possible. So I spent like around 3 years plus a bit. Then I finished already. Then I came back to Malaysia to pursue a PhD in UTM, Skudai, biosciences. Also doing a lot of molecular biology related work associated with bacteria as well. So that's where I kind of carved my new, like a very unique path actually, because it's quite rare for people to go overseas and then come back to do PhD. Usually they one shot finish everything there. So for me, it's like I don't want those kind of culture shock. I want to be able to assimilate my knowledge from overseas, apply what is good about them, and then see how we can marry that with the culture and the scientific research environment in Malaysia. So this makes my PhD quite an interesting journey It actually helped a lot to in ensuring that I can graduate on time as well.
So Gan, since you mentioned about you went to the United States, got your degree, come back to Malaysia, pursue your PhD. I think in this case, right, in Malaysia, what we call, they always have this headline saying brain drain. Our graduates are leaving the country, not coming back. I think it's very important in your case, right? You did come back, you did do your PhD locally. I think what I would like to add here is, instead of looking at only those leaving, I think we need to treasure those who are coming back, right?
Correct.
So what's your thoughts on that? People need to come back to, to bring back the knowledge and experience to the country, and how you have done from leaving after finishing a PhD to where you are now as a founder of Patriot Biotech. So can you, elaborate the challenges you faced when actually you took a goddamn step to come back, especially, from your last job in Deakin Genomic Institute?
Okay. So actually after my PhD, I spent some time in Monash in Malaysia, but after that I actually went to Australia to do my postdoc in Deakin. So I think the challenge, or rather the realization, is that when you are in other people's country, you're never like a proper citizen. You're always second class. You cannot deny how good you are, whatever it is, you're never one of them. So what I realized was I published so much paper, everything under Deakin University. Deakin University is not under Malaysia, and then it's good for my CV, but at the end of the day, it doesn't make sense. It doesn't feel right So I decided, I think better come back to Malaysia. Plus, Malaysia is my home. I got family in Malaysia, and then if I were to end up somewhere, Malaysia is the place that I want to end up in So the same thought that I have when I was in the United States as well, actually. So going to the Australia is good in the sense of getting more exposure. So the thing about this brain drain is real. It's very sad because people always say the grass is greener on the other side. Actually, the grass is greenest at your own home lah. You just didn't see it yet. But you have to go out there. Then only you start to realize the grass is actually greener on the other and the other side.
Okay,
Yeah.
so to all the JPS scholars funded by Malaysian taxpayers who's listening to this, better come back to make the country great, right?
Yes,
so talking
correct.
about how can we nurture biotech industry, as you and me, we know when we graduated, we get sell pipettes, we sell some PCR enzymes,
Yeah.
PCR machines, you know, so how can we disrupt the industry to democratize the biotechnology so that especially in the area where we are now, in a very interesting area because climate change is real, food is getting scarce, less arable land.
Okay.
So the country is importing about 70 billion ringgit worth of food, just doubled in last 10 years, that figures. And how do we perceive to tackle this climate change, yet we have less land to produce food? And how can we use our biotechnology to disrupt? Because every time when we talk about biotechnology, people get often confused with GMO food. You know, they think biotechnology means GMO. GMO is bad, right? So can you elaborate in much more, you know, in a simpler way? How can biotechnology disrupt, for instance, our agricultural system or the way we produce food?
Okay, can. So the way it works right now is that there are always traditional way of farming. Okay, those are not biotech. Those are just I would say the same old method lah. But the way biotech is supposed to integrate is not from the point of view of a genetically modified organism. You don't play that game. But there are just so many more aspects that can be looked into. So for one thing, what we know when we come to food security is there's always going to be disease. For example, so traditional point of view got disease, bye-bye lah. There's nothing you can do about it. But actually, if you play your biotech card properly, you will be able to find out what virus or what bacteria, what pathogen is actually causing the disease. Knowing that lets you win half of the battle because at least you know what you're dealing with. And this can be done using molecular approach. For example, PCR, this is what we did back during the COVID day. We can actually use PCR approach to see whether you have COVID or not. You can use the same method to see whether the plant or the crop, the fish, aquaculture species has that specific disease as well or not. And then on top of that, when talking about biotech, you can actually also do proper selection. We call it, we are trying to breed more disease resilient or faster growing aquaculture species or plant species. And that is not traditional way of waiting and do selection already. This is more like looking at their genetic footprint. So this is where new approaches such as genome sequencing can come into place to help identify important genetic traits that can be selected and used to facilitate breeding program. So no longer the day that you see this one big, very good, then you grow it. But we confirm at the genetic level what makes it strong, what makes it big, what makes it fast growing. We use that. It's more precise. It's like a surgical strike as well lah. To kind of use that, okay, this is the one that we're going to use because it has all these characteristics. It's backed by proper science, not just hearsay anymore. So this is where actually biotech can come into place. And then in terms of how we can disrupt this thing, we need to realize one thing. In Malaysia, it's not just food that we are importing. All the biotech region and all that, all are not made in Malaysia. Made in US, China, everything you import.
So again, before we dive further into that, so maybe you know we just really want to touch base a little bit more on the agricultural system, right? So we have monoculture system in Malaysia. We have oil palm for 6 million hectares. We have only rice fields. Of course, rice is our staple. It's very important. But can you imagine there's 6 million hectares of oil palm, and there is a 20% space in between. That's 1.2 million hectares, right? Which is laying idle. Right? So it's sad to learn when we look at 1.2 million hectares. That's probably as big as Netherlands, where they are producing agricultural products and supplying to the whole world. Here we have 12 months agroclimatic conditions. yet we are not doing anything about that, right?
Yes.
So for instance, so when you touch on biotechnology, right? So since we're talking on this, so people always say, oh, there is shade and there is no crops going to grow because it's not shade tolerance.
Right.
So is that something biotech can disrupt in a way that can we look into crops which is conventionally not cannot shade tolerance, but in this case you make them adapt to the new environment to make it, you know, to look into shade tolerance genetic properties, for instance.
Oh yeah, that's definitely one way you can actually look into it. Because the way it works is that when you have genetic diversity, meaning that there will be specific individual within a population that has a specific trait that makes it unique. What you need though is some sort of way to look for that trait. So this is where selection comes into place. So speaking of, for example, not plant species, but a specific trait that makes them more, I would say, can photosynthesize much more efficiently, for example. This is something that you can actually generate or produce using biotech approach as well. So again,
so this is where your next generation sequencing comes in.
Correct, yeah.
You can blast the data, can blast the genome quickly, rapidly, just to look for the traits, and you probably sometime we characterize this lucky enough to find the gene pool.
That's the lucky draw.
But why we say lucky enough? Because we need to repeat, right? Repetition is a cost, right? So if we make, as you say, the locally produced enzymes, locally produced tools, so that you have less cost barrier as a barrier to entry. So you can sequence anything every other day until you find that one lucky stuff, which is not technically lucky, but it's just repetition to find a particular trait. You know, what do your take on that? Yeah.
So the repeating step is important because you want to ensure that for the same trait, we are looking at the similar genetic structure or genetic marker. If you have that, then you really strike it already. And that's where how you can actually use that to then further look within the vast population for individual with the similar trait or similar genetic trait. And this can now be achieved using, for example, the genome sequencing approach or something more targeted as well. So rather than wait for things to grow and then only, oh, this is the right one, you can actually pre-screen them before they even grow up. So by selecting them and then using them for subsequent breeding program or even subsequent selective breeding work, you actually shorten the time by quite a bit. And in biotech, time is money. You cannot wait for things to grow. It takes a long time to grow. Only then you realize.
I totally agree. So if we have a one genome, 2 billion sequence, if every sequence is taken to revisit each sequence 1 second, 2 billion sequences is 100 years of time. And through next generation sequencing, you can intervene and disrupt the process. So again, going back to where we started and how you started Patriot Biotech with the idea of democratizing NGS in Malaysia, and I just want you to quickly introduce your entrepreneur aspiration, and of course we want to hear more about our BB33 or Black Box 33, which Patriot Biotech going to launch soon to democratize how we're going to detect disease in a rapid and more accurate way. So why not you touch base on that a bit more?
So first thing first, we start with the aspiration behind doing next generation sequencing. So the short, like to put it simply, this next generation sequencing is the ability to read the DNA sequence of practically any organism, virus in a very short period of time. It generates a lot of data, but as long as we know how to do the data analysis, it can be done very quickly. So the idea behind this is that when I come back to Malaysia, I realized that there's not many experts per se in NGS. Everybody talks about it, but they maybe do 1 or 2 projects.
Cakap saja lah.
Cakap saja. So no offense, just like it's an experience. Like okay, I do my PhD in my NGS, but it's only 1 project. Maybe I sequence 1 genome only. But what
was
I
this
realized,
Arowana you did microbiome?
Yeah. So for me myself, I guess not to brag or something, what sets me different a bit is that I take the path that's not
The weird part, the
weird
difficult
part.
part.
I sequence everything. I do everything.
So some examples, maybe audience want to know. You were the first
Yeah.
guy to sequence arowana, the most expensive fish.
Yes.
Nemo?
Yes.
Was it
Nemo?
Nemo?
We did Nemo as well, and then we even did the largest freshwater fish, the Macquarie perch. Not the maricot in Australia.
And of course, we did udang-gala together. So
Udang-gala,
that's our proprietary now, and with
yes,
the latest release genome.
Mm.
So yeah, so going back to that, yeah.
Right. So did a lot of genome sequencing. So I think what I realized is that the more things you do, the more things you learn. So that has to be the mantra in biotech. You cannot stop learning. Learning doesn't end like I finished my PhD, that's it lah. Cannot. If you want to keep challenging yourself, you have to take up new project. And
so since mentioned, I said finish by PhD cannot happen. But isn't it as a biotechnology graduate, even as undergraduate, you come up from university, that's the mantra, right? We got to be innovation. So it doesn't really, for me, if you ask me, we have a lot of colleagues here, it doesn't really takes a degree to achieve a certain level heights in the life or in the research innovation or master's degree or even like yourself with PhD. But do you really think, I mean, I know we are a little bit deviated, but I just want to set the tune right for the audience there, especially the mentality of graduates. They think that they finish degree, they need to get a master's in order to be qualified more to earn more. Then they go to PhD and then they think they qualified more to earn more. But end of the day, what they don't realize, they have not worked in their whole life. They have not touched anything on their own beside the guidance from the lecturers.
Which by itself is not a good thing because it's all in an academic-centric environment. This is not the real world.
Yes. So talking about academic-centric, I think this is what becoming grappling issues for Malaysian graduates, because we finish degree, we all want to get a job in the university. I want to be a lecturer, I want to be a senior lecturer, I want to be an associate professor. And come on guys, I think that's something we fundamentally, this is what we personally also trying to disrupt the way of thinking that there's many problem statement, there's many solution needed to make it as a business, and later on it can definitely travel as entrepreneurial journey. Sorry again, I just want to touch on that base because sometimes people think, oh, Dr. Gan, no, because he achieved all this because he got a PhD. Actually not. He probably even started earlier, right? But then I think it's always about job experience. You have to work in order to have enough experience. Failures, many failures, right? Lights are not invented in a day, Rome not built in a day, but failures meant to be success. So coming to that, so going back to Patriot Biotech and how you conceive next generation sequencing as the next frontier, and how that assimilated you to invent this BB33. Anyway, BB33 is not body to body, it's black box 33.
Yes. So the way it works is that as you do a lot of genome sequencing, actually you know more about the organism or the virus genome or genomic makeup. And with that, as long as you have that information, you can essentially design kits, for example, that can detect that virus. So you don't need to wait for a paper to be published, for example. If you know how to sequence the genome, you know how to analyze it, you can easily make a kit the next day. That's how quick it is. And that's the kind of speed you need in aquaculture. You cannot wait for 1 year to get something out. No. So BB33 actually right along that sort of thought as well. So the way it works is that with this black box 33, we are hoping that instead of sending sample out to a lab to be tested, farmers on the site can get their result and then get it uploaded to a phone, uploaded to the cloud. So this actually allows not just at the farm level, rapid testing, rapid recording of data, and anytime you need the data for historical purposes, you can just flip your phone and check. That's the beauty of BB33. BB33 measure presence of pathogen just based on the color change. Simple as that. And then as long as it's a pathogen,
and that information is digitalized.
Correct.
And they have it on site immediately. I think 33 means after 33 minutes, as you told me before. And this and just want to highlight this. This project got a funding from Cradle. Thanks to Cradle. Shout out to Cradle as they funded us. Cradle Rock, right? So going back to that aspiration, right? So yes, you had that idea. You put that idea. So how do you see the funding ecosystem have supported that? and how like GK Aqua as an aquaculture company is also supporting that to be scaling it up, that up.
I think this is a very important thing to kind of grasp, because like funding important to get project going, but you need to find the right partner, right environment to test out certain prototype or idea. Gone are the day you just randomly sit in a university, just come up with some random idea. It doesn't work
ivory
that
tower.
way. Ivory tower, the ivory tower syndrome. So called, you just think like, oh, this is gonna solve the world. You come up with some small thing. It never get tested. It never gone through that acid test, we call it.
Oh, acid test.
Acid test, meaning that whether it really work or not.
Oh, okay.
You make something in the lab, this is comfort.
Okay.
But when you test it out in the real environment, that's the acid test already. Is it gonna work? If it doesn't work, you have to go back to change, to fix it up. So I think in terms of the current ecosystem, it's a very nice lah. In terms of number one, we have a very strong aquaculture biotech company, which is where we are sitting right now.
Oh, thank you, guys.
Okay. Yeah, which is good because you don't want the traditional ways of doing hatchery or genetic breeding and whatnot. You want the right
disruptive.
Yeah, disruptive is the key, and then disrupt together is more important.
Yes,
you cannot do everything by yourself. So here we have the ecosystem to get it tested, and then very grateful that we got funding from Cradle, whereby we got the financial kind of assistance to actually
and also recognition.
Oh yeah, at the end of the day, recognition. You're in the system, you're in the ecosystem, means you're one of the members already lah in the club. That's very important. Why? Because you get to know people in the network who are doing different things. Maybe one day you can collaborate together. So that's where joint venture and all that.
So this is where we put startups together like GK Aqua, Patriot Biotech, Center Biotech as a synergist of different startups to disrupt the value chain to have a derived outcome. Just like not I'm disrupting the way udang gala is grown, just make it all male, but we also need to make sure it's healthy. You need to eat the right food. So it really matters how we can put different knowledge and different subject matter expertise in the room. So in the case of BB33, how you conceive it, you get few electrical guys, engineering guys, IoT guys, AI guys. So do you want to elaborate? Because in the university, we always want to work in multidisciplinary, right? You want to get project fundings for multidisciplinary, but does it really happening? Because it's always in silo mentality. So how do you find your experience and our experience putting this together? And you hate to work with me, I hate to work with you personally, but putting aside that hatred, but put the subject matter expertise together to really derive. Because I told you when we started the BB33, I did mention to you, we want to test each test less than $2, less than $2. And that was the mantra we played. And I told you, right? We don't care about how we want to do it, but just do it and make sure less than $2. So it's not that we invent a product and we price it, guys. So we actually priced it from day one. Whether it's profitable or not, we have no idea still. But it's working, the solution, and I think we'll fine tune in terms of the cost factors and how we want to scale up. So you want to touch more on this DIY digitalized BB33.
All right. So I mean, the DIY thing comes from the point that the farmers actually should be the one who is performing the test. Gone are the day you send it out to the lab to be tested. Speed matters. And secondly, simple enough to be used. It's on the apps, it's on the phone. You just press a bit, and then simple as that.
I think in next show you need to bring your demo and you're going to show the demo, right? Next show is coming out with real demo with real farmer, okay?
So now it's review first
Okay.
But in any case, speaking of the multidisciplinary thing, right? It's very important, but sadly, it's not really well practiced or seen at the university level. People tend to work in silo, and even though they agree to collaborate, the commitment is it's not there. They just collaborate for the sake of collaborating, for the sake of securing the grant. But after the money comes in, it's very rare for like people to see them all sitting in one room, brainstorming idea and all that. So it's very rare. Haven't seen that coming into fruition.
Yeah.
But coming out from academia, these are more and more possible. Because gone are the days that there's commitment to do lectures and secure grant. We're here, we want to solve problem, and along the line,
benefit the farmer 3 feet above the ground, right?
Yeah,
because
man.
many farmers we talked to, right, they said, yeah, you test, one thing is expensive. Secondly, when I test, I know it's all disease, so give me
Then
more
what?
headache.
Oh.
I have sleepless night, right? So in fact, we also are looking into RNAi solution technology to how to actually vaccinate the prawns, right?
Correct, yep.
So I think with that, right, I think it's wonderful. I think there's more. I think we can talk until 11 p.m. or 12 p.m.
Yeah.
But I think to keep it short within half an hour so that we don't bore the guys. So why not we take a quick this time, all right? And then we have next episode.
Boleh.
We test water, our first episode, how is it
Yes,
going? And then getting a lot of views. If we get view, we get support, we do that more, right? So any last words from you to the audience?
Keep disrupting, especially among biotech students, and never stop learning.
So hear that, guys. Going to school, studying life science. I mean, of course, I was a science graduate. When we graduate, very poor salary, right? We don't get jobs. People don't respect us. So we go nowadays study accounts. So STEM education for parents now, or even for kids now, it's not becoming very popular. I think with what we're trying to bring up now up to life, I think the world need more food with growing population from 7 billion to 9 billion. And the bottom line is we have less land to produce food to feed the 9 billion people. So the one thing we can do, as Gan said, as Dr. Gan said, and I call him Gan, all right? So Dr. Gan said, keep disrupting. So we got to keep disrupting to make more innovation, to produce more food with less arable diet. So with that, we are signing off for the day and looking for the next episode. Thank you, guys.